This is a 3D printer. It takes three-dimensional models saved on your computer and physically creates them right before your eyes. 3D printers are both fascinating and complex. Each year, the technology gets better and better. In this video, I'd like to walk you through one of these machines to show how it works. My name's Jared. I create 3D animations to show and explain how things work. Hit the subscribe button to be notified about future videos just like this one. This video is sponsored by Bambu Lab. In science fiction, they sometimes have this device called a replicator. You can ask it to make almost any object, and it somehow materializes right in front of you. Today, we don't have replicators, but the 3D printer is starting to do some of the same things. It doesn't happen instantaneously, but is still quite impressive at what it can do. 3D printing is a type of additive manufacturing. You start with nothing and then add materials layer by layer until it's complete. Compare that to subtractive manufacturing. Start with a block of material such as metal, and you remove parts from it to form the final product. Notice all the excess waste. With additive manufacturing, there is much less waste of materials. This is an advantage to 3D printing. Yes, it's true. A 3D printer can be used to create all sorts of toys, minifigures, movie props, you name it. But keep in mind that a 3D printer can be used to create objects that have a more practical use. A lid holder for your kitchen, zip ties, adjustable supports for just about anything, a Wi-Fi QR code sign, and even a customized broom holder. Very useful for your kitchen. You can even 3D print accessories for your 3D printer. You're only limited here by your imagination. In the real world, there are some other interesting uses. 3D printed food, yes, it really is edible. 3D printed clothes, and 3D printed prosthetics for those that need replacement body parts. Large-scale companies are using 3D printing to manufacture products because it's less expensive and quicker to produce. Companies like SpaceX are literally 3D printing parts of their rockets. NASA is hoping to use 3D printing to create items when astronauts are far from home. This means they don't have to bring as many tools and spare parts into space. And there are even 3D printed houses. Instead of plastic, they are made with a special concrete-like material. And yes, people actually live in them. It looks quite nice if you ask me. There are different types of 3D printing. The most common one, and the one used in this video, is called fused deposition modeling, or FDM. It takes a long strand of filament. This is usually some form of plastic, but it really depends on what you're printing. Then it melts it into a specific pattern to form a layer. These layers go one on top of the other until you've finally created your 3D object. The filament usually has a thickness of 1.75 millimeters, about the thickness of 2 credit cards. Filament for the printer we'll be looking at today comes in these large spools. You can get them in almost any color that you want. The filament comes in several different types, but don't worry, you don't need to memorize any acronyms here. Just know that PLA, or polylactic acid, is the most common and easiest to get started with. Some of these materials are more rigid, meaning they don't bend. Others are more flexible, and some of the advanced materials have more strength and can withstand extreme conditions. For this video, we're going to walk through the A1 3D printer by a company called Bambu Lab. This company is really on the cutting edge of technology and has a lot to offer. As of October 2024, the A1 costs $339 US. Bambu Lab has been working to get these 3D printers into the hands of consumers like you and me. The printer is about as big as a desktop computer. Very easy to put on a desk right next to your workspace. Let's take a closer look at the A1. This part is called the gantry. Your 3D object will be printed on a metallic build plate. This can be removed so that it can be washed or even replaced with a different one. It's held on by strong magnets directly underneath. There is a touchscreen right here to control the 3D printer, but you can also control it from another device such as a desktop computer or even your mobile phone. At the top of the machine, there is a plastic support arm that holds the filament spool. The end of the filament is hand-fed into the tube opening shown here. Then through the plastic tube, which connects all the way down to the tool head. Inside, the filament will be melted and come out the very bottom. Inside the tool head, there is a stepper motor, which will spin to pull the filament through to where it is melted. Now, in a regular electric motor, it uses electricity and magnetism to continuously spin in one direction. A stepper motor is different because it can be precisely positioned and will stay there until instructed to move again. There is another stepper motor over here. When this spins, it moves the belt that goes all the way across here. Moving the belt causes the tool head to move left and right. This bar is called the X-axis linear rail. There are 2 threaded rods on each side. You can actually see them if you move in far enough. When these spin, the rail and the tool head move up or down. They call these the Z-axis linear rails. This means the tool head can only move in 2 dimensions, but this is a 3-dimensional printer. For the 3rd dimension, the build plate moves back and forth on the Y-axis. Down below, there is another stepper motor that spins another belt. This is what moves the build plate back and forth. 3 dimensions of movement allows the printer to create your 3D models layer by layer. There is a camera up here to take images of the objects as they are built. You can even make a time-lapse video, which is really fun to watch afterwards. 3D printing can be as short as just a few minutes, or as long as several hours or even a day or 2 if your object is complex enough. The area inside of this imaginary box, this is called the build volume. You can only create 3D objects that fit inside of the build volume. If you want to print something bigger or maybe more complex with more integrated parts, you can still do that. You just have to find a way to print it in several different pieces. 3D printers from Bambu Lab come with a handful of 3D models ready to print and built into the 3D printer for easy access. This little boat is commonly referred to as a benchy, which is short for benchmark. It's a common first item that you print to test the speed and quality of your printer. To get more 3D objects, you can download them from MakerWorld or one of several other websites. Many of these are completely free. You can also create your own models in a 3D software, but this takes a little bit of learning to do so. You can even use 3D scanning to take objects in the real world and create the 3D model. But either way, once you have your 3D model, it needs to be converted into a format that the 3D printer can understand. Your 3D object will probably be in one of these formats. Then you take that and run it through a program called a slicer. This takes your 3D model and splits it into many distinct layers that can be 3D printed. The slicer uses this and produces something called G-code. This is the step-by-step instructions for how the 3D printer should create your 3D object. These are very specific instructions on how to move the stepper motors. This controls where the tool head and build plate moves, as well as when the filament comes out. Fortunately for us, you don't need to understand this G-code. You just need to send it over to the printer and it does the rest. So let's walk through an example and see this in action. Once you press the print button, the build plate starts warming up, as well as the hot end of the nozzle. Inside of the tool head, the stepper motor starts to spin, which pulls the filament through. The part at the bottom, this is called the nozzle. It's the piece that gets really hot. If you're using PLA, one of the most common types of filament, it will heat up to 220 degrees Celsius. Even with the protective cover, you definitely don't want your hands to get near this during the printing process. At this point, the tool head will come over to the left side and begin to purge some of the filament to make sure that it's flowing. This is called purge filament, or informally known as printer poop. Yes, the printer has got to put it somewhere. Many people will actually 3D print a special container to catch all of this purged filament. Now that the filament is flowing, the 3D printer will take additional steps to prepare for printing. One of them is called bed leveling. This is making sure that the build plate is completely level. Any offset could mean flaws in the 3D print. Bed leveling usually takes at least a few minutes. Modern 3D printers make bed leveling automatic, much easier than previous generations of 3D printers. Right before it actually starts printing, it usually draws a few lines at the front to make sure it's still flowing correctly. At the back of the build plate is the nozzle wiper. Make sure the hot end is nice and clean. And after all of that, we are finally ready to start printing. The first layer is extra important because it has to stick really well. This is why the build plate is heated. The build plate is usually textured to help it stick a little better, but sometimes a special glue is used. Oftentimes, the printer will draw the outline of the layer first and then the inside. This inside part is called the infill. You could make this part completely solid, but that would be a waste of filament. It's common to do about 15% infill, just enough to give it structure on the inside so that it maintains its shape. When it's done printing, keep in mind that the build plate will be hot, so use caution, but you should be able to grab your new item within a few minutes. It cools pretty quick. Here's the A1 3D printer in action. Let's take a look at this 3D model. When printing the overhanging portion of this model, it would be necessary to print into thin air, which is not possible. For something like this to print correctly, it needs to have supports added. It's the green tree-like structure that you see here. Another example, let's try to print the gateway arch. In my last video, we saw that during the construction, it would have collapsed without using extra supports. The 3D printer is doing this at a much smaller scale, but the same idea still applies. The Bambu Lab software allows us to add supports that will be printed along with the original model. You'll notice that the 3D printer does okay with some overhang, but once it gets to the top, we need those supports. When it's done printing, the supports can be broken off. Look at that, 3D printed gateway arch. There was a time when you could only print 3D objects in one color, but the A1 3D printer has the ability to print in several different colors. For this to work, you need a separate device called the AMS Lite. That stands for Automatic Material System. This connects directly to the A1 printer. You have room for 4 different filament spools. And then there are 4 clear plastic tubes that connect the AMS Lite to the A1 printer. This is called the filament hub. The end of each filament spool is fed into the holes inside the AMS Lite, and a motor starts pulling it through the tube. Filament spools from Bambu Lab have an RFID chip. Using this, the machine automatically knows the type and color of filament. Very convenient, so you don't have to manually enter this. When it starts preparing to print, the AMS Lite will push the first filament through and the melting process begins. The 3D printer will warm up and calibrate just like we've seen before. When that's done, we're ready to start our 3D print. At some point, the printer gets to a place where it needs to switch colors. The tool head moves over to the side. It will press this lever against this piece sticking out here. Inside the tool head, you can see that pressing the lever cuts the filament. The filament is now retracted up until about here. Then the second color is pushed into place. Notice how we still have a bit of old filament inside of the nozzle. We can't start printing until we get rid of this. The tool head moves over to the other side to get rid of this extra filament. Let's take a closer look at what happens on this side. We have a small lever here. When this lever is pressed, it moves the sweep. The tool head moves over and presses this lever. Then the purged filament comes out. It has to do this long enough to completely get rid of the old color. When the tool head moves back, the sweep will get rid of the purged filament. Now the printer is ready to continue with the next color. This was a simple 3D print because the filament really only had to change once. Now take something like this. The color will need to be switched many times on an object like this. It takes longer and there is a lot more waste, but that's the trade-off to get your 3D objects printed in several different colors. The A1 is an entry-level 3D printer. You can do a lot with it, but there are some downsides. It's informally known as a bed slinger. This is because the build plate actually moves back and forth. This means you'll need to plan for a little more counter space. And the rapid moving back and forth can sometimes be a problem when you start printing out larger 3D models. It's also 3D printing out in the open. There's no walls enclosing this area. That makes it impossible to control the temperature and humidity during the printing process. Let's take a look at one of the more upgraded 3D printers that solves some of these issues, the X1 Carbon, also made by Bambu Lab. A more expensive model, but there are many advantages to this. The first thing is that it's fully enclosed to control the climate inside. There is a glass panel on top and a glass door in the front to access the inside. Up at the very top is the tool head. It can handle higher temperatures, giving you finer control over the materials and quality of the final print. The X1 carbon is referred to as a Core XY. The toolhead does the moving on the X and Y axes, and the build plate moves up and down on the Z axis. Compare that to the A1 bed slinger that we saw earlier, rapidly moving the build plate back and forth. The X1 carbon provides a lot more stability, rapidly moving the toolhead, but slowly moving the build plate up and down as 3D objects are printed. The X1 carbon has 3 threaded rods. When these spin, it moves the build plate up or down. The X1 carbon uses something called LiDAR, which will scan the first layer to check for any problems. On the side, there is an improved camera that will monitor the rest of the printing process and take time-lapse videos. It is a bit darker inside just because it's enclosed, but the chamber LED light makes it so you can see a little better. Here's the fan to better control the temperature and filter the air in the chamber. On top, you can usually put your AMS to print in multiple colors. Notice on the A1 printer we had the AMS light, but this one is just called the AMS. It has a lid to fully enclose your filament spools. This keeps out the moisture, allowing for a higher quality of 3D prints. If you're interested in a 3D printer similar to the one shown in this video, click the link in the description below. The future of 3D printing has never looked brighter. Thanks again to Bambu Lab for sponsoring this video. My name's Jared. Thanks for watching.